My name is Keith Stakes. I'm a research engineer with the Fire Safety Research Institute and currently the Deputy Fire Chief for the Bethesda Chevy Chase Rescue Squad, and I will be your narrator for this training. We will cover everything you need to know about the floor below nozzle and its usage in the Montgomery County Fire Rescue Service as a tool for wind-impacted fires. The purpose of this training is to ensure that all personnel and partners of the Montgomery County Fire and Rescue Service are brought up to speed on the scope, methods to deploy, and operation of the floor below nozzle as a tool for wind-impacted fires. The floor below nozzle is a tool to provide an alternative means of water application when direct, on-plane access to the fire is limited due to wind-impacted conditions, obstructions, or other limitations. There are 5 training objectives that will be covered within this lesson. Number 1, an introduction to the science of wind-impacted fires in tall buildings and an explanation of what signs may be present to indicate these conditions. Number 2, a demonstration of the steps to deploy and properly operate the floor below nozzle. Number 3, an explanation of the expected change in conditions when the floor below nozzle is operated efficiently into the fire compartment. Number 4, a demonstration of a typical interaction between incident command and the unit officers who are responsible for deploying the floor below nozzle. And number 5, a description of the procedures to clean, maintain, and store the nozzle. In wind-impacted fires, traditional access to a fire compartment from the interior of a building on the fire floor may be extremely difficult to impossible, as crews may have to attempt access via the exhaust portion of a wind-impacted flow path. Wind speeds of as low as 10 miles per hour can drastically impact fire conditions, ultimately affecting the life safety of trapped occupants and the corresponding firefighting response. The video playing to the right is from a series of fires conducted at the Maryland Fire and Rescue Institute with the Montgomery County Fire Rescue Service and the Fire Safety Research Institute. The top 2 video views show footage, both standard as well as thermal, from the stair landing adjacent to the doorway to the fire floor. The bottom left and bottom right video views show both a standard and thermal view of conditions in the hallway just outside the fire room. When the red banner in the center of the video pops up indicating a start of wind conditions, you see a drastic change within the hallway. Fire, heat, and products of combustion go from bidirectional to unidirectional, driving that heat to the floor and to the stairwell door itself. A high convective flow with radiative components is extremely dangerous for both any trapped occupants as well as the responding firefighters, making access from that direction downwind, again, difficult to nearly impossible. This video shows a test conducted by the National Institute of Standards and Technology, looking at wind-impacted fires. On the left, we see an exterior view of a fire compartment with a fire growing and spreading within the room, also with a 25-mile-per-hour wind present to the exterior of the building facade. To the right, this is a thermal imaging view of the public hallway, opposite of the fire compartment. The door to the public hallway is open. The video shows the window failure as the fire continues to grow and spread within that compartment, increasing heat and therefore pressure. As the window fails and the fire begins to become wind impacted, we see an immediate change in conditions in the public hallway to not only untenable but downright dangerous. The flow goes from bidirectional to unidirectional and is not able to be overcome by firefighting hose lines or a show of force. An alternative means of water application is necessary. There are several size-up cues that are critically important to understand and recognized to indicate the presence of wind-impacted fires. From the exterior of the structure, you should be on the lookout for the following: the presence of a unidirectional intake into a fire compartment or compartments, an open or failed window with little to no smoke or fire exhausting from that vent, or smoke or flames pulsing in and out of windows due to pressure fluctuations within the fire compartment. From the interior of the structure, high pressure against doors when opening them, smoke pushing from around the doors, either the stairwell or the fire apartment, any flame travel within the corridors themselves, or floor-to-ceiling smoke or flame, indicating a unidirectional flow path. This video is from a test also conducted by NIST in conjunction with the Fire Department of the City of New York, taking a look at the conditions present with the impact of wind. The top left video view is from the outside of the high-rise, looking at the fire compartment with wind present. The top right video view is from the fire compartment itself. The bottom left video view is a view from the public hallway with the fire apartment door open, and the bottom right view is from the stairwell itself. As the wind impacts the fire with the window failed, we see that there is a fire burning to the interior of the compartment. However, there is little to no smoke or fire exhausting from that window opening, indicating that the wind currently has a higher pressure than the fire on the inside, also indicating likely that there is another lower pressure exhaust elsewhere. In this case, that is the open door to the public hallway and open door to the stairwell. On the inside of the building, we see a unidirectional flow path in the public hallway with rapid floor-to-ceiling smoke and flame travel directly towards the stairwell. This video is from another test by NIST, taking a look at the conditions present with wind-impacted fires. As you can see from this video, the wind can increase the pressure into the fire compartment such that the interior pressure can periodically become higher than that of the wind, in which you will see the fire burp out of the window intermittently. This is not an animation, these are actual fire conditions present. If this is noticed during a size-up or at any point during the fire operation, this should be communicated to those on the fire ground. It is also important to note that this phenomenon can happen both with or without the fire department door open. The Montgomery County Fire and Rescue Service operates under the principles of fast water and coordinated ventilation, as indicated by the incident response policy. Wind-impacted conditions may prevent an initial traditional interior attack on the fire floor of the building. When wind conditions are present, coordinated ventilation now means controlling the stairwell door to the fire floor and holding on any additional ventilation until an alternative means of water application can be accomplished. For example, the floor below nozzle. If the fire floor is within reach of exterior streams, including a large caliber handline, a portable ground monitor, an engine deck gun, or an elevated master stream, one of these tactics should be accomplished while interior crews maintain a safe haven behind the controlled door from the stairwell to the fire floor. The floor below nozzle is a tactical option for these significant fires that cannot initially be managed by a traditional interior attack or is out of the reach of exterior streams. When considering this tactic, command must take into consideration the following. It can take longer to deploy than a traditional handline, and it will typically require 4 to 5 personnel to place the device in service. Upon recognition of a wind-impacted fire, crews assigned to the fire floor should take the following actions. Immediately make incident command aware of the perceived wind-impacted fire. Immediately attempt to control the stairwell door and seek refuge. Identify if the designated attack stairwell and your current location is either upwind or downwind. If upwind, proceed towards the fire apartment via a normal, traditional interior attack with extreme caution and maintain control of the stairwell door behind. If downwind, maintain control of the stairwell door and request units to investigate other points of access for suppression that are upwind, or possibly an alternative means of water application. If the fire has vented and is within reach of exterior streams, crews should attempt one of the following actions for initial knockdown and control: a hand line, a portable ground monitor, an engine-mounted deck gun, or an aerial-mounted master stream. These 4 video views show examples of traditional means of applying water from the exterior of the structure. Top left, a hand line of appropriate size and caliber. Top right, a portable ground monitor. Bottom left, an engine-mounted deck gun, and bottom right, an aerial-mounted master stream. It is important to note that this form of water application should include the usage of a straight or solid stream and not any form of a fog stream, as that can entrain too much air into the structure and not provide adequate surface cooling to the interior. This video that you are about to watch from Assistant Chief Alan Bush covers the current engine deck gun specifications and reasoning behind setup and tip selection for the apparatus currently in the Montgomery County Fire and Rescue Service fleet.
All right, so good afternoon. We're here to talk about the deck gun. So when we're talking about applying water from the exterior of the building and doing it quickly, one of the options that we were thinking about is how do we do that effectively with the deck gun? And then what are our options, whether we're using tank water or using hydrant water? So when we thought about using tank water first, one of the primary considerations is the size of the tank to pump piping. And so on the Crimsons, like what we're on now, that's a 4-inch pipe that's fairly large. On the Pierces, it's a 3-inch pipe, which is smaller, and that only allows you 500 gallons per minute. So if you think about the traditional tips that are on the deck gun, this one's been outfitted with what we're carrying now, but the traditional style is 1 3/8 inch, 1.5 inch, and so forth. So right from the get-go, if you're using the 1 3/8 inch, you're starting at 500 gallons per minute. With the next size tip, you're going to 600, etc. So the challenge from Chief Bailey, who was the operations chief at the time, was, hey, is there a way that we can get the same or better reach and penetration, but use less water, and that way we can utilize the tank water more efficiently? And you also have to think about the amount of time that it takes to set up and aim the water stream, etc. So we did some testing, and what we came up with is the 1 1/8 tip, which is on here now. We sent out the fleet management bulletin that talked about that and what the expected flows are. So roughly at 80 pounds for a master stream, you're going to get about 300 gallons per minute out of this tip. So if you're doing the math, really what that equals to is 2 minutes and 2.5 minutes worth of water out of this tip. There's more time allowed for sloppage. If you're aiming and you're not quite right and you have to move the gun, etc., or whatever, then you're good to go. So that's how we ended up with the 1 1/8 inch. So you still have options in terms of the gallonage. If you go to hydrant operations where you're not flowing off the tank, you have 300, 600, 800, or 1,000. So that's a nice range. When we bought the 1 1/8 inch, what we realized is there was no way to put the 1 3/8 inch in the series. So that's why we told you to store it in the engine driver's compartment. We didn't really think we were losing anything, because if you think about it, an 1 3/8 inch tip flows 500 gallons. The next size up is 1.5 inch. That goes immediately to 6. Not a big difference between 5 and 6, but there is a difference between 3 and 6, so we thought that that was a better option for you. When we were doing some testing in this, we did see that the reach and penetration was a little bit better. with the 1.125", and the stream was quite nice. There wasn't a whole lot of turbulence. The other thing that we thought about was the speed and the manpower required to put the deck gun in operation. So unfortunately, with these pull-up style of deck guns, we're not able to put a valve up here that can be controlled. So this really has to be a two-person operation. The engine driver is going to have to pressurize the gun with the valve control and the throttle below. Somebody's going to have to be up here aiming it. If the engine driver was operating by himself, he would have to go ahead and open the valve, throttle up, and then jump up here and try to aim. And that's not a really good, there's just a lot of time wasted there. The other thing about that is once the deck gun valve is open, we really don't want to be trying to put the deck gun up and down. So if the deck gun is down and nested and then you charge it, trying to push the handle in and pull the gun up, it's all under pressure, not really safe. So we wanted to be able to put a valve up here, but once we started thinking about the pressures involved in the mechanisms, we just decided that that wasn't going to be safe. There are some engines out in the fleet that have a swing-up style of deck gun. You're going to see that on the new E1s that are coming. With those, we are able to have a valve controller up here. So that's going to be a one-person operation. The engine driver can carry that out on his own. But you'll see that in a later follow-on video. We're not going to be able to show that today.
It is important to recognize that it's both possible and likely that the apparatus that delivers the floor-below nozzle to the scene will not be available to assist with the deployment, as they will likely already be involved in other fireground operations. The floor-below nozzles within the MCFRS fleet are currently assigned to the following apparatus: Truck 706, Truck 715, Truck 716, Aerial Tower 719, Aerial Tower 723, and Aerial Tower 724. The devices were placed on these apparatus based on the presence of a high number of high-rise structures within the first due and adjoining areas. The floor-below nozzle is a two-piece configuration, constructed that way for the ease of both transport and storage. It has an assembled length of 75 inches. The nozzle itself integrates a 2.5-inch Elkhart XD shutoff. You will need a 2.5 to 1.5-inch reducer for operation with a normal 1.5 or 1.75 hose line. It has a 2.5-inch National Hose Thread female swivel base, which is the inlet, with a 1.5-inch National Hose Thread male outlet. The intended setup is a 7/8 tip flowing 160 gallons per minute. The nozzle itself has a 100 psi operational pressure rating. The desired number of personnel to deploy the device is 5. However, a minimum of 4 could accomplish the task. The intention here is for the marrying of 2 units. 2 unit officers are required, one to enter the building and supervise the operation, and the other to serve as the outside spotter for nozzle placement. Crews should be prepared to remove windows below to deploy the device as needed. Standard commands. The commands are transmitted by the outside spotter in reference to the nozzle tip and the interior crew's orientation. For example, tip up, tip down, your left, or your right. As you can see from the video playing on the right, the nozzle is being operated from the floor below into the wind-impacted fire compartment above. There is a unit officer to the exterior of the structure, maintaining radio contact and guiding the nozzle placement. The video on the right is another test from NIST, looking at wind-impacted fires and the expected changes from the operation of a floor-below nozzle. With water application into the wind-impacted fire compartments, the following should be seen: an immediate reduction in the heat release rate, otherwise known as the fire's power. Also, an immediate improvement in conditions in both the fire area as well as the public corridor. As you can see in the video, as soon as the water makes contact with the fire compartment, either via the fire compartment ceiling or frame of the window, the fire is rapidly knocked down. We see the public hallway go from high heat and flame travel floor to ceiling to conditions that are now tenable to resume a traditional interior attack. This video compilation is from the series of fires conducted by the Montgomery County Fire Rescue Service and the Fire Safety Research Institute. The top left, you can see the exterior of the structure and the application of the floor below nozzle. The top right view shows the rooftop stairwell tour. The bottom left and bottom right show conditions from both a standard and thermal view in the public corridor just outside the fire room. Prior to the application of water, it can be seen that in the public corridor there is high heat and floor-to-ceiling smoke and flame spread to the stairwell. Upon the application of water, the fire is instantly knocked down, the heat is removed from the public corridor, and conditions are now safe to resume a traditional interior attack. The video that you are about to watch shows an ideal deployment and operation, along with a typical interaction between Incident Command and the unit officers responsible for the deployment of the floor below nozzle on a fire ground where wind-impacted conditions are present.
Engine 718 with a side Charlie report. I've got smoke and fire pulsing from an open window.
Fire attack command. There's flame travel in the corridor. We are back in the stairwell. We are unable to make the fire department. I'm closing the door.
Sounds like we have a wind-driven fire. Who do we have on the box with a floor below nozzle?
Tower 719 is on the initial alarm.
Okay, we'll use their floor below nozzle. I need 2 units to get that nozzle in service. Who do we have?
Tower 18 and engine 725 have not been assigned.
Okay. Engine 725 and Tower 718, come to the command post. All right, there's a wind-driven fire on the 10th floor. The fire is in apartment 1019. I need you to take your crew to apartment 919 and get the floor below nozzle in service. Tower 718 officer, you're going to be the floor below nozzle group leader. Select one person to be the outside spotter and use 7 Alpha 6 to coordinate nozzle placement.
Paramedic engine 725, charge the line. Paramedic engine 725 to tower 718. Are you ready for us to start flowing?
Tower 718, you paramedic engine 725, that's correct. Pull it back slightly, come back to your left. So you're good right there, hold him right there.
Fire attack to command. The conditions in the hallway have greatly improved. We are now able to make the fire department.
Command to fire attack. The floor below nozzle put a good knock on the fire, and I'm also seeing improved conditions from the exterior. Go ahead and proceed to the fire apartment. Acknowledge.
Copy.
High-rise incidents may also involve rapidly spreading exterior fire involving the building materials, such as cladding. Water will need to be applied from the exterior, if possible, for effective knockdown. If the fire is located above the reach of traditional exterior methods, the floor below nozzle can be deployed adjacent to the fire area for knockdown. In this video, you can see footage from a fire that was located in Valencia, Spain, that unfortunately took the lives of 10 civilians. The fire started within an apartment in the structure and very quickly spread to the outside. Within 15 minutes, flames had involved the exterior cladding of the structure and reached the top of the building. Within 45 minutes after the fire extended to the outside of the structure, the remainder of the exterior of the building was involved. This became a very difficult fire for adequate suppression and knockdown. Combustible cladding fires do not just occur overseas. Within Montgomery County itself, there are several examples of structures, both new and older, which have combustible cladding features. The two pictured here are 180 High Park Lane and 1040 Spring Street. Two additional examples of buildings within Montgomery County that incorporate combustible cladding are 1230 Spring Street and 8616 2nd Avenue. The examples pictured, both here and the slide before, are within areas that have a high prevalence of high-rise fires and also are the location of the floor below nozzles deployed to the Montgomery County fleet. The floor below nozzle is a tool that can also be used to combat combustible cladding fires. A combination tip from one of the Elkhart breakaway nozzles can be placed onto the end of the floor below nozzle and flowed either upwards or downwards onto the exterior facade of the building as needed. It should be noted that this should be utilized if the window for nozzle access is in close proximity to where the fire is located. If further reach is needed from the point of flow, otherwise known as the location in which the nozzle is being applied from, a smoothbore tip can be placed onto the floor below nozzle and utilized for either an exterior cool down of the facade at a distance or for direct application into a fire room window at greater heights. For example, when the floor below nozzle is being applied from more than one floor below where the fire is actually located. The floor below nozzle should be cleaned with soap and water after each training evolution or deployment on an incident scene. The nozzle should be inspected monthly and again before each deployment. You should ensure that there is no debris in the waterway of the nozzle and ensure that the bail functions properly. You should inspect and exercise the locking hardware prior to charging the device with water. And lastly, the device should be mounted in the apparatus in a compartment that does not require climbing or deploying the area ladder for access. Thank you for participating in this training on the usage of the floor below nozzle for wind-impacted fires in the Montgomery County Fire and Rescue Service. If you have any further questions, feel free to contact me, Keith Stakes, Battalion Chief Robert 1st, or Battalion Chief Christie 1st. Stay safe.